Dear students, welcome to Physics World. Today we are going to study about the floating and sinking of the bodies. Floating and sinking. Now suppose we know that a piece of cork floats on water while iron sinks in water. Now why this is so? This is so because in class 7 we have already learnt that the density of the cork, which is 0.25 approximately gram per centimeter cube, is less than the density of water at 4 degrees Celsius, which is 1 gram per centimeter cube. On the other hand, the density of iron, which is 7.8 gram per centimeter cube, is greater than that of water at 4 degrees Celsius. Because of this, because of the comparative densities, the cork floats on water and iron sinks in water. So now let us see what makes a body float or sink in a liquid when it is immersed in that liquid. Suppose a body is immersed in a liquid, then there are two forces. There are two forces acting on the body. One is the downward force, that is the force that is pulling it downwards, and that is the weight W of the body. So there is one downward force acting on the body, and there is also an upward force acting on the body, that is called the upthrust or the buoyant force. It is also called the upthrust because it is the upward force, and it is also known as the buoyant force. It is the force exerted by the liquid displaced by the immersed part of the body. So over here, if we are going to make a diagram of a body which is been immersed in water, so over here we can see a part of the body is immersed in the water, and a part of the body is above water. So we can see over here that there are two forces that are acting on it. One is the downward force, that is the weight acting from the center of gravity downwards, and the buoyant force in the upward direction. Now there can be certain cases. The first case, when the weight of the body, that is the downward force, is greater than the upward force. That means the downward pull is greater than the upward force experienced by the body. So it is obvious that it will come down to the bottom slowly, and that is it sinks. Now let us consider a second case where the weight of the body is equal to the upthrust experienced by the body. This happens when the density of the body and the density of the liquid are equal. So the net force, that is the net downward force that is acting on the body, that is 0. Whether you call it downward force or upward force, over here it is downward because we are taking W minus FB. So this is the downward force acting on the body is 0. So therefore the body floats just inside the surface of the liquid. Suppose this is the surface of the liquid, this is the outer layer of the liquid, and the body floats with just inside the surface of the liquid. So this will be the situation for this case when W is equal to Fb, or weight of the body is equal to the upthrust experienced by the body. Next is the case 3, where the weight of the body is less than the upthrust experienced by the body. You can understand that the downward force is less than the upward force experienced by the body. In that case, what will happen? The body will be pushed up and up and up till the time W becomes equal to Fb. Now this is a concept where the children sometimes get confused. See, when as long as W is less than Fb, it will be pushed up because the upward force is greater. So it is being pushed up. How long will it be pushed up? Till the time W becomes equal to Fb. That means that much part of the body will be immersed in the water. The weight of the liquid displaced of which will be equal to the weight of the body. This case arises when the density of the solid is less than the density of the liquid. Now let us see, there are certain important takeaways over here. The first important takeaway is, if the density of the body is greater than the density of the liquid, then it sinks. If the density of the body is less than the density of the liquid, then of course it floats. If the density of the body is equal to the density of the liquid, then also it floats. So these are the three important takeaways from these discussions. Now we shall discuss the law of flotation. When will a body float on any liquid? When a body is placed on a liquid and it floats, then obviously the downward force and the upward force, they must be equal. So W must be equal to Fb, that is, mathematically we can say that W is equal to Fb, where W is the weight of the body and Fb is the upthrust. So the law of flotation states that for a floating body, the weight of the liquid displaced by the immersed part, what is Fb? It is the weight of the liquid displaced by the immersed part is equal to the total weight of the body. So this is one of the frequently asked questions. What is the apparent weight of a floating body? Sometimes it is also asked that what is the net weight experienced by a floating body, or net weight of a floating body. So these are the most frequently asked questions. So let us see how to answer this question. We will always explain anything with the help of some law or some equation which we have learned. So we have learned the law of flotation. We will say that by the law of flotation, for a floating body, W is equal to Fb. Please mention W stands for the weight of the body. Weight of the body. And Fb stands for the upthrust. Therefore, the apparent weight or the net weight experienced by the body, W is minus Fb, that is equal to 0. So apparent weight of a floating body is 0. Then again, this one is another frequently asked question. An iron nail sinks in water, but a ship made up of iron does not. Why? So over here you have to bring in the concept of average density. So let us see how we are going to answer this question. The density of iron is 7.8 gram per centimeter cube. Now children, for answering this question, the density of iron, knowing the value of density of iron is a must, which is greater than the density of water at 4 degrees Celsius. Mention the density of water at 4 degrees Celsius, and hence it sinks. Whereas a ship has a lot of hollow spaces which is filled with air. Now the density of air I have mentioned over here. Now if you do not remember it, you can simply write down, which is much lesser than the density of water at 4 degrees Celsius, and hence the average density. Here the concept of average density comes in, because the iron is there and inside there is a lot of hollow spaces. That hollow space is filled up with air, so the average density of an iron ship becomes less than that of water and it floats. So the things which are important over here, first you need to remember the density of iron. You need to remember, of course you know the density of water at 4 degrees Celsius, so that has to be mentioned, and then the concept of average density has to be mentioned. Dear students, that will be all for today. I will be coming up soon with the videos of the other chapters as well. Thank you for your cooperation and all the best for your upcoming examinations. Thank you.